Hello everyone, welcome to JEE Maths PYQs Master Series. Today's problem is an official JEE Advanced 2021 Paper 1 question from complex numbers. At first glance, this question looks very lengthy and intimidating, but don't worry, it is actually based on a beautiful combination of geometry, complex numbers and trigonometric inequalities. Let us decode it step by step. We are given 10 positive angles theta 1, theta 2, so and so forth, theta 10, such that theta 1 plus theta 2 plus so and so forth, theta 10 is 2 pi. The complex numbers are defined as z1 equals e power I theta 1 and zk equals zk minus 1 into e power I theta k for k equals 2, 3, etc. 10. We have to determine whether statements P and Q are true. Let us understand what the definition means. Let's expand first few terms. Z1 equals e power I theta 1, Z2 equals Z2 minus 1 into e power I theta 2, that will be Z1 into e power I theta 2. Z1 is e power I theta 1 into e power I theta 2 e power I into theta 1 plus theta 2. Similarly, Z3 equals e power I into theta 1 plus theta 2 plus theta 3 and so on. And finally, Z10 will be e power I into theta 1 plus theta 2 plus so and so forth plus theta 10 e power I into 2 pi, because it is given in the question here, which is cos 2 pi plus I sin 2 pi. That gives Z10 equals 1 plus I into 0, 1. Notice something important. Every complex number satisfies mod Zk equals 1. So all 10 points lie on the unit circle. This is the biggest observation of the problem. Exam trick: whenever you see e power I theta, immediately imagine a point on the unit circle. This is a unit circle with radius 1 and this is a point on the unit circle e power I theta. Many JEE advanced problems become much easier when viewed geometrically instead of algebraically. Now let us prove the statement P. We know that mod Zk minus Zk minus 1 is simply this chord joining two consecutive points on the unit circle. Now recall an important identity. For two unit circle points separated by this angle theta, their chord length equals 2 sine theta by 2. This can be understood from the property that perpendicular from center O to the chord, say AB, bisects the chord, from which we can find the chord length to be 2 sine theta by 2. Hence, mod Zk minus Zk minus 1 is 2 sine theta by 2. Therefore, statement P equals 2 times summation k goes from 1 to 10 sine theta by 2. Now use the standard inequality sin x is less than equal to x. You can test it with any standard angle 0, 30, 60, 45, etc. Therefore, for every positive x, 2 sine theta by 2 will be less than equal to theta k. Adding all 10 inequalities, P will be less than equal to theta 1 plus theta 2 plus so and so forth plus theta 10 equals 2 pi. Hence, P is true. Here remember one thing. 2 sine theta by 2 is the chord length corresponding to angle theta by 2, whereas theta k is the corresponding chord length. Obviously, chord length will be less than the corresponding arc length. Now let's prove the statement Q. Consider z square k. Since zk equals e power I theta, we get z square k equals e power I 2 theta. Squaring doubles the angle. Again, all these points remain on the unit circle. So the angle which was theta previously has become 2 theta now, and the chord length which was AX previously has now become AB twice as much. Now mod ZK square minus ZK minus 1 square equals 2 sin theta k. Hence Q will be 2 summation k equals 1 to 10 sin theta k. Again using sin x less than equal to x, we obtain 2 sin theta k less than equal to 2 theta k. Adding we get q less than equal to 2 times theta 1 plus so and so forth plus theta 10 equals 2 times 2 pi 4 pi. Therefore q is also true. We have already proved p is true. Therefore option C, both p and q are true, is correct. Common mistakes. Students commonly make these errors. First, treating mod zk minus 1 as arc length instead of chord length. Number 2, forgetting the identity mod e power ia minus e power ib equals 2 sin mod a minus b by 2. Third mistake, missing that z10 equals 1 because the total angle is 2 pi. Fourth mistake, forgetting the inequality sin x less than equal to x. This single inequality solves both statements. JEE Advanced takeaway: whenever you see exponential form e power I theta, modulus, or distance between complex numbers, immediately convert the problem into geometry on the unit circle. Then remember these two powerful identities: mod e power ia minus e power ib equals 2 sin mod a minus b upon 2 and sin x less than equal to x. Together they solve many advanced level questions elegantly. If this geometric approach helped you understand the problem better, please like, share and subscribe to JEE Maths PYQs. In the next video, we will solve another official JEE Advanced Complex Numbers PYQ with smart concepts, quick exam tricks and complete step-by-step explanations. Stay focused, keep practicing, crack JEE.